podcast. My name is Derek Yu. I'm the CEO of PureStake, and I wanted to, take a little bit of time today to talk to you about some of the work we're doing related to Ethereum compatibility on Substrate. We are kind of taking a lot of this work that we're doing with Ethereum compatibility on Substrate and are going to be incorporating that into our project called Moonbeam. So I just had a few slides I was going to go through to explain kind of what the project is, and I'll give a little demo to demonstrate some of these Ethereum compatibility features, and then I'll pass it off to a couple of the engineers, a couple of the technical folks on the PureStake side, who can dig a little bit into some of the more technical details, some of the architecture of the system, and even some of the things that we're working on now. So why don't I go ahead and just kick things off here. So the first question, what is Moonbeam? Well, it's going to be a parachain that's deployed to both Kusama and Polkadot. We are going to have two separate parachain deployments, much like Parity has done with having these two separate networks in the first place. And that the idea, the motivation is kind of similar. That we'll be deploying code to Kusama first, where it will stay for some amount of time and be vetted before that code is promoted to the Polkadot mainnet. I mentioned Ethereum compatibility, so really putting a lot of our energy into working on these Ethereum compatibility features. We strive to kind of create an environment that is as compatible with the existing Ethereum both toolchain and network as possible. Some of the elements of that include a Web3 compatible RPC set of endpoints that are in our implementation, as well as a full EVM implementation that comes from Substrate, from the Palette EVM that's part of Substrate. The goal is to create this option, right, for people. Substrate itself obviously is quite powerful and can be used to create parachain or parathread, and that's going to make sense for some projects. But having smart contracts as an alternative mechanism, to provide kind of a backend for an application, that's a valuable alternative. And so we want to kind of help support this kind of smart contract option, with these Ethereum compatibility features as an alternative to parachains and parathreads for when those make sense to use. And I would say that kind of our motivation in kind of becoming interested in Polkadot, digging into Substrate and kind of building this project is we really are big fans of the interoperability vision that's part of Polkadot. And, so we're quite keen on, adding support for these interoperability features as they become available on both Kusama and Polkadot. So as those features, XCMP and Spree, as those are added, to both Kusama and Polkadot, we'll be incorporating those features and making them available to folks that are developing on Moonbeam. So, a little bit a background of who we're trying to help and kind of what the what the goal is of our project. A lot of the folks that we're speaking with in terms of developers that can use our platform are folks that have existing projects on Ethereum. And, as many of you I'm sure are aware, there are some challenges right now on Ethereum in terms of cost, particularly gas costs for end users. And just given kind of what the costs are for different kinds of actions on Ethereum, it could be the case that either existing workloads are becoming very expensive or kind of too expensive to support, or there could be things that projects want to do that they just can't do because they're cost prohibitive. So what we're trying to accomplish is to basically help existing projects kind of complement and extend existing projects that have existing Ethereum deployments. So this would be kind of moving workloads, helping them move workloads from Ethereum to Moonbeam. And kind of at the same time as helping them with their workloads, they kind of can then expand their reach into kind of Polkadot, right? As the Polkadot ecosystem grows. And I would say that the somewhat unique thing here is that almost everyone we're talking to is interested in kind of this hybrid deployment, right? Where they don't want to leave Ethereum. There's plenty of important things happening there. That's kind of their main base of operations. They maybe have dependencies on other DeFi services, other projects that they're kind of integrating with on Ethereum. But this idea of being able to take some of their workload or some of their functions and kind of extend their application out to the Polkadot ecosystem via Moonbeam is something that's interesting because basically any change needed is kind of minimized if you can provide this Ethereum compatible environment. So that's kind of from the kind of project side. I think we also have some goals around helping the Polkadot ecosystem itself. So we spoke about kind of being this easy on-ramp for existing projects and developers, but there is this kind of whole thing about tools, right? So Substrate has an awesome set of development tools for building parachains, parathreads, runtimes, and front end components to applications. But there is a whole existing set of very mature and capable tools from the Ethereum ecosystem. And so being able to use those on Moonbeam, it gives choice, and choice is good, right? I mean, there's definitely a lot of things to choose from in the existing Ethereum toolchain that may be good solutions to problems that developers are facing. And as I mentioned, kind of this cross-chain integration, we kind of see ourselves in the longer run as these cross-chain integration features get deployed onto both Kusama and Polkadot. Now we're really interested in kind of testing and kind of implementing integrations with other parachains, on those networks, and then kind of having these pre-baked integrations available on Moonbeam that developers can consume and use. And we think that there's going to be value in that, and kind of having these kind of pre-built integrations, be they for Oracle services or even just tokens that are able to move, that will be valuable as those features become available. So rather than kind of talking more about it, I thought I would just flip now to show you just a quick demo of some of the functionality that's available. And so what I'll do first is, if you see my terminal here, I'm just going to start up. We can purge our chain here just to make sure that we're starting from a clean slate. And I'm going to start a Moonbeam node. This, of course, is just running in dev mode. So this is just a local node, local Substrate-based node with our runtime and with some of the Ethereum compatibility features in it. And you can see here, just kind of as usual, you see blocks being produced as you'd expect on a regular kind of Substrate node. And then what I do have a kind of a cheat sheet here, so you'll see me kind of pop this open from time to time. So one thing I'll do up here is I will pull up Polkadot.js, the applications, and you can see here it's defaulting to connect to my local development node. You can see here, like it's kind of detecting these blocks as they're being produced, just the regular standard, Polkadot.js apps. Next, let's install MetaMask here. So I'm just going to paste this link, which goes right to the Chrome store. I'm just going to add the, just out of the box MetaMask to my Chrome installation. And let's go ahead and just get started. And I'm just going to let it create a wallet. I'll agree to this. Let's pick a password. And it'll just remind me later on that. So here we go. So now we have MetaMask installation in Chrome, just out of the box standard. What I'll do now is I'm going to import an account. So we have, there's a Genesis account in the Moonbeam node that I just started that already has some funds in it. So I'm going to go ahead and import an account here, and I have the account secret here. So let me paste this, kind of in. And so now there's, if you look here, there's an imported account, and then there's the account that I just created along with the MetaMask installations. We have 2 accounts now in our MetaMask. One other thing I'm going to do a couple more things. So I'm going to add advanced gas controls. I'm going to turn these on. There are a couple instances when we're working with Moonbeam that we're going to need to specify a specific gas limit. So let's do that. That's a little bit of a quirk for now. And then last but not least, I'm going to go to this Networks tab. And so right now we're connected to the Ethereum mainnet, but I'm going to add a network. So let me add, I'll call it Moonbeam Dev. And let's add this RPC endpoint here. And our chain ID is 43. So note that this RPC endpoint, so this is just pointed at my local machine, 9933. So this is the same, substrate standard RPC port. But this is kind of where things get interesting, right? So obviously MetaMask isn't, speaking substrate. On this port, we're basically able to handle substrate RPC calls and standard Ethereum style Web3 RPC calls. When we looked at Polkadot.js apps, that's using Substrate. MetaMask here is using, Web3. So let's go ahead and save this. And so now you can see up here that we're connected to Moonbeam Dev. And you can see here also that, in account 2 that I imported, there's a balance, already there. So that kind of makes sense. So we have a balance in the imported account. We don't have a balance in the account that was just generated. So let's just go ahead and try some of the functionality. So for example, I'm just going to go ahead and send from this Genesis account to the account that got created. Oh, I don't know. Let's just say that we send 100. And I mentioned before that we need to kind of specify a gas limit here. So let's just specify this, which is I believe the maximum gas limit that's allowed. So I'm going to go ahead and send this transaction. And yeah, I think that the MetaMask UI just recently changed actually in the last couple of days. So it looks a little bit different now where they have this kind of tabbed approach. But you can see here that, this transaction was just sent. This it was a 4 before, so the balance kind of went down. And if I flip over to, my other account, now there's 100 tokens basically in this account. So that was just using, kind of, the Web3 RPC that's part of Moonbeam to, perform a transaction. Just want to show like maybe another example here of interacting with this local Moonbeam node I have. Let's try using Remix. So Remix, I'm sure many of you are familiar, is one of the prevalent IDEs for creating Solidity smart contracts. So I'm going to go ahead and configure Remix here for Solidity development. And if you look here, I do have a contract that's let's make this a little bigger. That's kind of loaded in here to Remix. This is an extremely simple ERC20 contract. So it's using the Open Zeppelin ERC20 templates. And in this case, the contract is creating an ERC20 called MyToken. It has a symbol MyTalk. It uses the default 18 decimal places. And really what it's doing is it's just taking the entirety of the specified supply and it's assigning it back to the creator of the contract. So pretty simple, few line, ERC 20 here. And so what I'll do is let's go ahead and compile this contract. And you might see down here that Remix is pulling in all of the Open Zeppelin dependencies that are needed to compile the contract. It's successfully compiled. And so now if we go to the deployment screen, one thing we're going to want to do here is I'm going to change the environment to injected Web3. So this is going to pull up MetaMask that we were just working on, and it's asking me now for permission, to use the Web3 provider that comes along with MetaMask. So this is fine. I'll go ahead and grant permission here. And so you can see here that this is the account that we created, and now it detects, that there's 100 tokens basically in the account that's in MetaMask. One of the arguments that we need to supply here when we're creating this ERC20 is basically the initial supply. So let's just do that. I'm going to put that value here. The initial supply in this case is actually 8 million. There's a whole bunch of zeros here because of this, 18 decimal places that we've specified. So it's actually 8 million followed by 18 decimal places. And so let's go ahead and kind of deploy this. And it's going to ask me here, I'm going to do one thing. I'm going to copy this kind of gas number again. Oops, let me pull this back. And let's put this gas limit, kind of increase that a bit. And then let's go ahead and deploy this contract. And you can see here, I'm not sure if it's covered here by this thing on the bottom, but that did perform a deployment action. And so you can see here that, here is basically the deployed contract. And, if I start interacting with it, for example, the symbol is my talk, the name is my token. Here we see the 18 decimals. The supply is this 8 million number. And then we can even do something like we can take the contract or the address from which we deployed the contract, this account up here. If I copy that and I check the balance basically of this account, I get back the total supply. So this is basically a deployed contract deployed onto this Moonbeam node I just started via Remix. Now let's do one thing. So I'm going to take the contract address here. I'm going to copy it, and let's go back to MetaMask here, and let's add this ERC20. So I'm going to go to custom token and paste in the contract address of the contract we just deployed. And you can see here that it kind of detected what the symbol was and what the decimals were. So that's a good sign. Let's go ahead and kind of add these, and you can see now that the account from which I deployed the contract, has this supply now of 8 million MyTokes. And we can even send these. So let's send it this way. I'm going to send to my other account that's in here. And again, let me specify a valid gas limit here. And I'm gonna actually, I didn't, hang on, let's do, I don't know, let's do some amount here like this. And let's actually, hold on one second. Let me, put some more tokens here. There we go. And then let's confirm that. And so you can see now that, this ERC20 is kind of in the process of being transferred, from the deployed contract that we just deployed. So, and now the balance has kind of been reduced here. So I think I'll probably stop there, and hopefully that gives a sense of some of the kind of Ethereum compatibility features that we have in Moonbeam. I'd kind of flip back here to our Polkadot.js apps, and you can see here that there's different events that are happening kind of on the Ethereum on the EVM side within Substrate. So again, we're using kind of the Substrate RPCs now to interact with our Moonbeam node, using Polkadot.js apps. And, there's kind of two different ways you can interact with the Moonbeam node, right? You can use the Web3 APIs, you can use the Substrate APIs. There's information here. And, even as an example, I'll just quickly kind of do an example here that if you, want to look at something like chain state, we can do this. Here is the Genesis account again that we've been working with. Let's kind of just use the chain state to query this, and you can see here that this is kind of the balance that we've been working with on that Genesis account, which has been slightly reduced. So I think hopefully that gives a sense of the kinds of things that you can do with the Ethereum compatibility features in Moonbeam. So what I think I'll do now is I'm going to hand off to Telmo to start to talk a little bit about some of the technical, kind of architecture and some of the details behind Moonbeam.
Thank you, Derek. Well, hi, everyone. My name is Tomo. I'm a developer in the Moonbeam project. And as Derek mentioned, we've been focused on Ethereum support development for the last months. And I thought that this could be a good opportunity to share with you guys the current Ethereum landscape status. So I don't know if Derek, you're sharing the slide.
Yep, let me go back. And there we go. And let me just present here. So you should see it now.
Yeah, thank you very much. So at the core of Ethereum support, there's this Ethereum virtual machine implementation in Rust. And in order to enable Substrate users to interact with that crate, we need to expose a set of dispatchable functions and lay out the right storage items to store account and account codes. And that is the role of the EPM palette. So with those two components, you can already execute smart contracts on a substrate-based chain. In Moonbeam, we thought from the very beginning that maybe Ethereum support is not only smart contract execution, but also open this compatibility with existing dApps and tools and workflows, and that is where the Ethereum palette and the Frontier model comes into play. The Ethereum palette is, and I will talk about this in the next slide, but the Ethereum palette, what basically does is emulates Ethereum blockchain inside a Substrate blockchain. And the Frontier project is this full support for Web3 API and the RPC that are on the Ethereum specification. So we can on the next slide. Yes. So I wanted to also talk about a bit on the palette Ethereum. So palette Ethereum, what it does is it is basically Ethereum block and transaction processing emulation. So the strategy we follow here is very simple, is that we follow the Substrate chain block protection base, and we take advantage of the unfinalized method to do something when for example, the block number 2 is finishing. So at that particular moment, what we'll do is to grab all the pending transactions that happen from the block 1 to block 2. And we create and store a structure that follows the Ethereum specification. So that's why the Frontier project is able to now query the Substrate storage by, for example, a H160 encoded hash that happens to be the Ethereum hash, and get the expected response, the response they will get in the Ethereum network. So yeah, in the link at the bottom, you can see how the palette Ethereum is implemented. Yeah. So in the next slide. Yeah. So I also thought that could be interesting today to show what is the current status of Parachains, and what Party did is a great job in the recent weeks to push forward the Cumulus development. So Cumulus framework is very useful for taking an existing runtime for a standalone Substrate-based chain and wrap it around this Cumulus runtime. And automatically having the ability of having a parachain out of that. So in Cumulus, what you have is a relay chain, and that let's imagine this is a West End a relay spec. So the parachain, the Moonbeam parachain, will be wrapped around that relay chain spec. So it has this ability to interact, to follow the relay spec, and this ability to what it's called to collate the blocks the parachain Moonbeam is producing. So I wanted to also share with you. So what is the current Moonbeam status as a parachain? Because many of you will probably know that Polkadot does not have the ability of executing smart contracts by design. So it lets the parachains to augment this initial capability. So the Moonbeam project aims to be a parachain and rely on the relay chain to give the finality to it. So in this official link, you can access the Cumulus project, and also I wanted to share with anyone that wants to try the current experimental test we're doing with a parachain. In this experimental branch I have on this Cumulus fork on our organization. So if you follow the steps I wrote in the README, you will be able to set this relay chain. Polkadot, I think, is based on a West End spec. You will be able to build a parachain that has all these landscape of Ethereum tools, and you will be able to replicate the demo that Derek showcased early on the parachain context. So of course, this is not production ready. So this is just a experimental test but definitely a first step to showcase that Cumulus and Moonbeam in its current status is able to offer Web3 compatibility and also the ability of executing smart contracts on a parachain context. And yeah, for me that will be it. So I pass it to Alan, I think. Derek?
Yeah, that would be great. Thanks, Tomo.
Thank you.
And it would be great if we could, if Alan can join. Maybe I'll stop sharing here.
All right. Can you actually share again?
Oh, okay. Yeah. Sorry.
That'd be great.
Sure.
So hi, everyone. I'm Alan. I lead the technical development of Moonbeam. And today I'm going to talk about two different topics. One being the challenges we are facing by using Substrate to build Ethereum compatible blockchain. And the second part will be about testing Moonbeam and how important it is for us. So talking about the challenges with the account compatibility, this comes with the fact that we are using Substrate, which is a very good framework. It allows a lot of modularity, but it also comes with some expectation on what your type and structure should be to be able to support all the great features that they have. So here, for example, you can see the structure for the account data, which contains the free balance and the reserve balance and few other properties. Those are kind of necessary because if you want to support like staking, governance, and many other features, you need to be able to have some reserved amount that the user cannot freely use. And obviously, those are not natively supported by Ethereum, so it brings some kind of incompatibility between the structure and the types that we want to use. Another difference is from the account ID itself. So the account ID is how basically you're going to map someone's transaction to actually its storage, its balance, and all its data. And the default for Substrate is the H256. And you can configure it in Substrate, but most of the modules are actually based on that. So on the other side, the Ethereum is actually based on the H160. So they have different length, and we need a way to make it work together. The third challenge we are facing is with the signature, because Substrate was originally based, or at least developed with the idea of using SR25519 as signature, while the Ethereum is using the ECDSA. So now Substrate support multi-signature, which includes ECDSA also. But it comes also with the challenge that the conversion from the public keys that you get with the signature to the account ID is different from Substrate to what Ethereum is doing. So if we want to be able to support the same private keys to use at both of the accounts, we need to do some changes there. And the last one is about the features that are offered by Substrate, because Substrate was built after Ethereum. It comes also with some great new features, like I was talking about staking, governance, and many others. And we need to make those compatible with Ethereum if we want to use them. So if you can move to the next slide. Yes. So we came with three different options that we are currently experimenting. The first one is about unifying the accounts. So instead of having on one side the Substrate account data and the EVM account data to a different structure, we would merge those into one account data. But for that, we need to solve the account ID. So we are trying to modify Substrate to be based on the H160 account ID and to use the ECDSA signature for it. But this still has some challenges, because what does it mean for Ethereum to have a reserved balance in that case? What should we do with it? We have few ideas in mind, but we are still experimenting with that option. The second one is about synchronizing the account. So you can easily imagine that you'll have the Substrate in one side with its structure, the Ethereum on the other side, and every time there is one transaction from one to the other, we'll just basically synchronize the balances between the two. But once again, this brings some other challenges, like what happens if one has some requirements that the other one cannot match during a transaction, or also a few other challenges that are the same as unifying the accounts that I talked before. And the last option is about transferable accounts. So we still have two different accounts, but when someone wants to use its token for Ethereum transactions, smart contracts, or other parts, you would have to transfer your Substrate tokens into the Ethereum account. This seems very easy, but the difficulty is that once you want to use Substrate feature, you will have to transfer back your token to use them. So let's say, for example, you're a developer, you start to move your token to use some smart contract, and then you want to use those tokens for governance or staking, then you'll have to turn them back. And here with Moonbeam, our priority is to make it easy and great for the Ethereum developers to actually use it. So right now, we are mostly focusing on the first option, which would make it very easy because the address system would be the same, everything would be unified. And that's what we are mostly experimenting with. Now, the second topic I want to talk about, if you can, well, yes, is about testing and why it is important to do it in Moonbeam. So one priority at Pure Stake is the security, mostly of the hosting solutions that we provide, but also of the software that we develop. So that's why we're putting a great effort on testing for Moonbeam. So let me show you, explain you a little bit about different kind of tests and how they work. So first, we have some kind of guarantees that comes with Rust, because Rust was picked for that reason is that it has a very strong mechanism of guaranteeing the stability of your code. I mean, once it compiles, it runs. But it doesn't guarantee that what you write is what you want to do at the end. So on top of that, we have the unit tests that are there to guarantee the logic of each palette. So for example, the palette balance, if you want to withdraw a certain amount, you want to make sure that the balance of that account is lower after. So those are part of the unit tests. On top of that, we have the integration tests, which are including multiple palettes together and making sure that the expectation of one palette matches what the other one is doing. So for example, if we want to slash an account from one of the palettes, we have to make sure that the balance will actually reduce the balance of that user. So it relies also on the fact that the balance is working properly as it's verified by the unit test. If you can move to the next slide, please.
Yeah.
And then we have a bit less common testing that is done for Moonbeam that we are working on. So you have the functional testing. It's basically testing the Moonbeam as a developer, like a black box, where you don't see what's happening inside, but you want to make sure that it behaves the way that someone using Moonbeam is expecting to. So for that, it's starting actually a full node of Moonbeam, where we are running the test through the RPC API. So mostly the Ethereum RPC API, because we want to ensure that the Ethereum developers are going to get what they want from the nodes. And on top of that, we have a more continuous, I would say, testing that guarantees the state of the chain over its development. Because one particularity of a chain is that it's not something that you can just turn off, change, and turn on again. Chains are supposed to stay permanent. And for that, we are working on testing a chain that is constantly running and which contains the same configuration that Moonbeam would have. And the tests will are basically similar to the functional one, but they will be executed against a real chain that is running. Yeah, and that's pretty much it for the testing at Moonbeam. We think it's a really important thing, and we're putting a lot of effort in it. And yeah. Thank you.
Great, thanks, Alan and Telmo. So that's pretty much what we had to share today. I guess I'll flip back and see if there have been any questions. But I wanted to just also mention that put up some information here about how to get in touch with us. We do have a Riot that we'd love to hear from you on if you're interested in exploring kind of any of the features of Moonbeam or developing an application. We do have a doc site which was recently launched, which has a number of the demo scenarios I went through and more kind of documented on that site if there's something that you want to kind of try out for yourself. So I wanted to kind of get that information out to everyone. And let me kind of flip back and see if there's been any questions. So there is one question here. Do you plan on somehow replaying the whole Ethereum chain to prove 100% compatibility, or is this an ill-conceived idea? I haven't heard about that idea, from anyone yet. It's an interesting idea because I guess there is like a data set there that contains a whole bunch of state transitions. So you could try to replay it and see if you arrive at the same state, I guess, at the end. That's an interesting idea. So I kind of appreciate that idea from Joseph, and it's definitely something that we'll keep in mind as we figure out ways it might fit into one of those kind of higher level testing kind of scenarios that Alan spoke about. I think that's kind of it from us. Wanted to kind of give everyone an update and kind of share some of the things we're working on, and we really kind of hope to hear from you and hope that you try out Moonbeam and some of the features. And some of the features on it. So Hutch, I think that's kind of all we had for today.